Part A of this 2016 Leaving Cert High Level Paper 1 Question 2 is a modular equation. When find the range of values for x, which the absolute value of x minus 4 is greater than or equal to 2. Okay, let's solve it algebraically and then we look at a graph to find out just exactly where the solutions are. So if we square both sides, we're going to get x squared minus 8x plus 16 is greater than or equal to 2 squared, which is 4. So x squared minus 8x plus 12 is greater than or equal to 0. This factorizes quite simply to be x minus 6 by x minus 2, greater than or equal to 0. So if it was a pure quadratic, we'd say x is equal to 6 or x is equal to 2. Because it's a modular equation, we'll do a little sketch here just to have a look at these solutions. So at what point does this touch the x-axis? But when x is 4, this is going to be equal to 0. So I'm just going to do a sketch here. So 4, and we know these modular equations, they go off in this direction and this direction. Now, when is it greater than or equal to 2? So that's my y value. So I just draw a line across here and imagine that this is 2, this point. It has to be greater than, so the modular has to be greater than 2. So it has to be along here or along here. So in fact, we have to be, x would have to be, and it's greater than or equal to, it would have to be greater than or equal to 6. If we imagine that this point here is 6, and it would have to be less than or equal to 2 if we imagine that that value there is 2. So why did I write 66? Greater than or equal to 6. So our two solutions, x greater than or equal to 6 or x less than or equal to 2. In part B of this question, we're asked to solve the simultaneous equations. So it's one linear, one non-linear. So we need to write x or y in terms of the other. So if we say 2x is equal to minus 3y minus 1, x is equal to minus 3y minus 1 over 2. So we need x squared and we need x times y. So why don't we do them individually? X squared is equal to minus 3y minus 1 over 2 by itself. Now, when they're all minuses on top, we're going to get all plus answers because a minus by a minus is a plus. So we're going to get 9y squared plus 3y twice plus 1. And on the bottom, we're going to get a 4. So x times y is minus 3y minus 1 over 2, all times y. So we're going to get on top minus 3y squared minus y, and on the bottom just 2. So that's xy. We have x squared, and actually we can have it in order here. X squared is this one, plus xy, plus 2y squared equals 4. So if we multiply everything by 4, we're going to get 9y squared plus 6y plus 1 minus, the 4 will go here, so it'll make it a 2, put the 2 on the bottom. So minus 6y squared minus 2y plus, and we're multiplying this one by 4, 8y squared. And then we're going to need to form a quadratic here. So I'm going to bring the 4 across. It'll be a minus 4 times 4 minus 16 equals 0. So I have a 9 plus 8 is 17 minus 6 is 11y squared. I have a 6y minus 2y is plus 4y. And I have a 16 and a minus 16 and a plus 1 minus 15 equals 0. So this should factorize for me. 11 is prime. These will always factorize in this question. You won't have to use the quadratic formula. 11y by y is 11y squared. And we want to get 4y. Okay, that has to be a 15 and a 1. So we need a plus 4y, so I need plus 15 minus 11. So y is equal to 15 over 11 minus 15 over 11 or plus 1. And we need to sub these values back into x here, minus 3y minus 1 over 2. minus 3y minus 1 over 2. Okay, so just use your calculator here. X is equal to minus 3 by minus 15 over 11 minus 1 divided by 2. So that would give 45 over 11 minus 11 over 11 is 34 over 11 divided by 2 is 17 over 11. So 17 over 11 minus 15 over 11. And my other value is 1, so I get minus 3 by 1 minus 1 over 2 is minus 3 minus 1, which is minus 4 over 2, which is minus 2. So minus 2 for x gives me a value of y of plus 1. So nice question to appear.